Hello everyone, in this video I'm going to teach you how to find the domain, range, vertex, axis of symmetry, and opening of the parabola with this given equation y equals x squared plus 8x plus 4. Remember, the standard equation of a parabola is y equals ax squared plus bx plus c. A is the numerical coefficient of x squared or the leading coefficient. B is the numerical coefficient of x, and C is the constant term. This is our given equation, y equals x squared plus 8x plus 4. Let's write down the invisible numerical coefficient of x squared. It's positive 1. And let's define our A, B, and C. A is equal to 1, B is equal to 8, C is equal to 4. First, let's determine the opening of the parabola. The opening of a parabola is dictated by the given value of A. If A is less than 0, or A is negative, the parabola opens downward. And your graph will look like this. If A is greater than 0, that means A is positive, the parabola will open upward. And the graph will look like this. Going back to our given A is equal to 1, and that's positive. Therefore, our parabola will open upward. So our graph will look like this. Next, let's solve for the vertex of the parabola. Remember that the equation for the x-coordinate of the vertex is x equals negative b divided by 2a. So simply substitute a equals 1 and b equals 8 into this equation. We can have our x-coordinate. It's negative 8 divided by 2 times 1. It's equal to negative 4. To solve for the corresponding y-coordinate of negative 4, you simply substitute x equals negative 4 into the given equation, then solve for y. Y equals negative 4 squared plus 8 times negative 4 plus 4. It's equal to 16 minus 32 plus 4. Let's simplify this. 16 minus 32 is negative 16, plus 4, it's negative 12. The y-coordinate of the vertex is negative 12. The vertex is at negative 4, negative 12. For the axis of symmetry, the equation is the same as the equation for the x-coordinate of the vertex. It's also x equals negative b divided by 2a. And we already know that negative b divided by 2a is negative 4. Therefore, the equation for our axis of symmetry is x equals negative 4. Next, let's find the domain of this equation. Domain is the set of x values. Remember that any quadratic function in y equals ax squared plus bx plus c form, or any parabola, regardless of whether the parabola opens up or opens down, the domain is always from negative infinity to positive infinity, or all real numbers. Let's validate the domain by referring to a graph that opens upward and a graph that opens downward. So if we have a parabola that opens upward, These arrowheads indicate that no matter how we extend the graph, it goes on forever and ever towards this direction and this direction. It keeps on expanding to the left towards negative infinity and keeps on expanding to the right towards positive infinity. That's why the domain is from negative infinity to positive infinity. The behavior of a parabola that opens downward is also keeps on expanding to the left towards negative infinity and keeps on expanding to the right towards positive infinity. Therefore, regardless of the opening of the parabola, the domain is always from negative infinity to positive infinity, or all real numbers. Lastly, let's determine the range of the quadratic function. For the range, we need two information. What are those information? The opening and the vertex of the parabola. Let's consider a parabola that opens upward. The vertex of a parabola is the minimum point of the graph. Let's represent the vertex as HK. H is the x-coordinate of the vertex, K is the y-coordinate of the vertex. These arrowheads indicate that the graph goes on and on towards positive infinity. It's endless. It goes towards the positive infinity. And remember that up for upward is always associated with the positive infinity and the inequality symbol greater than or equal to. And also remember that the range always has the y-coordinate of the vertex. So a graph that opens upward will have a range starting from the y-coordinate of the vertex, which is also the minimum value of y, towards positive infinity. So range of any parabola that opens upward is from k to positive infinity. This is in interval notation. You can also express the range in inequality notation. Remember that up is also associated with the inequality symbol greater than or equal to y greater than or equal to k. This is in inequality notation. Next, let's consider a parabola that opens downward. So the vertex is the maximum point of the graph. The vertex is at HK. The y-coordinate of the vertex is the maximum y value. And these arrowheads indicate that as you extend the graph, it goes on forever towards negative infinity. And remember, downwards is always associated with the negative infinity and with the inequality symbol less than or equal to. So the range of any parabola that opens downward is from k to negative infinity. This is in interval notation. Using the inequality notation, the range of any parabola that opens downward is y is less than or equal to k. Let's go back to our problem. We have a parabola opening upward and the k is negative 12. Therefore, the range is from negative 12 to positive infinity. This is expressed in interval notation. Or in inequality notation, the range is y is greater than or equal to negative 12. So these are the answers for this problem. It opens upward. The vertex is at negative 4, negative 12. The axis of symmetry is x equals negative 4. The domain is from negative infinity to positive infinity, or all real numbers. And the range is from negative 12 to positive infinity, or y is greater than or equal to negative 12. If you have any questions or you want further clarification, just leave a comment. Please don't forget to subscribe to my YouTube channel. I am Tutor Marife MCP. Thank you for watching.